particles are localized and bounce off each other. An important aspect of collisions between particles like these is that the momentum of the system is the same before and after the collision. Momentum is the mass times the velocity. In nature, this quantity is conserved. We'll use this law of nature later on when we start colliding particles to see what happens. Waves, on the other hand, are spread out and pass right through each other. When they move through each other, they interfere with each other. They can even interfere with themselves, creating interesting patterns. Newton thought light was a particle because he never witnessed light diffraction. The wavelength of light was too small for the experiments he ran. For decades, his view was never questioned. But in the early 1800s, that changed based on experiments by Thomas Young. Here we see light traveling through two slits and then interfering with itself on the other side. A diffraction pattern is etched onto the back screen. This is the famous double slit experiment. When Thomas Young did this double slit experiment, he showed conclusively that light diffracted and therefore was a wave. Here's his sketch of two-slit diffraction that he presented to the Royal Society in England in 1803. Because of diffraction, instead of seeing points, each point is spread out into a disk called an airy disk. The resolving power of any optical instrument is its ability to produce separate images for two adjacent points. This resolving power of optical microscopes is about 0.2 micrometers. The bottom line is that you can't see a thing that is smaller than the wavelength of the light used to illuminate it. If we're going to do better than 0.2 micrometers, we'll need to use something else to do the illuminating. And for that, we'll need to get a better handle on the nature of waves and particles.